there. Okay, types of reactions. Friday, we did balancing. Now that you're experts at balancing, we're going to be talking about 5 basic types of reaction that you're going to be responsible for. This morning, I'm just going to give you the overview of how you recognize them, like with a general equation, and then we're going to be talking about the synthesis and decomposition because they're opposite. So I usually teach those together because one of them is composing reaction, the other one is decomposing. So they're literally opposite. Okay. So the general equations for these 5 that we're going to be responsible for, composition or synthesis, I will use those words interchangeably. I prefer the composition because that lets me know it's opposite of decomposition, but some of the resources or printed materials you'll see will call it synthesis. Some even call it combination, but that's more of an old school term. But basically the general equation is A plus B yields AB. So we have 2 simpler things making a more complicated thing, okay? For decomposition, I just told you it's the opposite, so it's AB breaking down into A plus B. You can use any letters. I'm just choosing A and B, okay? I'm just choosing those. These are not real elements. These are just general, okay? A single replacement is one element will replace another in a compound. So it's going to look like this. A plus BX will yield AX plus B. Basically, A kicks out B and takes its place, and now B is all by its little self. Okay. You can also replace the second thing, but when we get to single replacement, I'll explain how you know, am I replacing the first or the second? It depends on if it's a metal or a non-metal. Okay. Double replacement is like they're doing the do-si-do. Everybody's switching partners. So AY plus BX is going to yield AX plus BY. Generally, those are going to all be ionic aqueous compounds when we're doing that. So it's going to be a metal and a non-metal, and then the metals switch place with the non-metals in there. Okay, and then combustion are the easiest ones to predict what they're going to make because they all make the same thing. And the way we know it's a combustion is you'll see a hydrocarbon, which we talked about last week. So we'll go CXHY for numbers there because they can be all kinds of things. And what do I always have to have if I'm going to burn something? Oxygen, O2. And then combustions with hydrocarbons, I told you on Friday, who remembers, they always make water. CO2 and water. Good job. Y'all remembered. Okay? So those are just the general equations that help us know, hey, that's a single replacement, that's double, or whatnot. Okay? So you will be responsible for this. Okay? Again, if you got to somewhere where I was asking you this, you don't have to use the exact letters that I'm using, just as long as you're showing the general what's happening. Okay? So let's talk about synthesis or composition reactions. And that is going to be where 2 or more simple substances, they can be elements or compounds, combine to form one more complex substance. We're going to recognize synthesis or composition reactions by the fact that there is only one product. So they will only make one product. Okay? So you have a list in your notes of the different things that they could make. Okay? I encourage you, when we're doing these, utilize the list. Okay? Because you don't know these things if you're not referring to them. So refer back to this list. Every year, people are like staring at it and go, I have no idea what it makes. I'm like, where are your notes? It tells you. So you should have your notes out while you're doing these. Okay? So let's look at the examples. Okay? If I have a metal and a non-metal reacting, I'm forming an ionic compound or a salt. Okay? Most of you think salt is just NaCl. Okay? That is a class of compounds. Salts are a class of compounds. It's not just NaCl. Okay? So if I have metal and a non-metal, I'm going to form an ionic compound or a salt. Okay? If I have 2 non-metals, I'm going to form a molecular compound, right? 2 non-metals make 7 molecular compound. So here's some examples here. Excuse me. 2 compounds may form a single product. For instance, I could have sulfur trioxide plus calcium oxide, and it's going to make calcium sulfate. This one has a typo. It says a metallic oxide plus water may form an acid. I want you to cross out acid, and I want you to write base, and then arrow hydroxide. They'll form a hydroxide. Okay, so if I have magnesium oxide plus water, I'm going to create magnesium hydroxide. If I have a metal oxide plus CO2, it's going to make a metallic carbonate. I can substitute any metal. I'm using magnesium as an example, but you can substitute any of those. A metallic oxide plus SO2 is going to make a metallic sulfite. And then a non-metal oxide plus water will give you an acid. Okay? So let's practice a couple of these. Any questions so far? All right, let's practice. If you know their state of matter, go ahead and put it down. If you're unsure, you can leave that off. Okay? I'm not very, very strict about putting the state of matter, except when we get to double replacements. Okay, when we get to double replacements, you have to say whether it's a solid, liquid, or gas, because that determines if a reaction actually happens. Okay, so calcium. These are not in your notes. Write them on the bottom of the page or on the side where you got a big spot. Yeah. Calcium plus oxygen. How do I write calcium when it's all by its little self? Ca. Oops, I forgot to tell it what I was going to write. Hold on. There we go. Ca, we know that that's a metal, so it is going to be a solid, right? How do I write oxygen when it's all by itself? O2, because it's one of our diatomics, right? Solid, liquid, or gas? Oh, sure. So what would calcium and oxygen join up to make? It's a metal and a non-metal. Calcium oxide. How would I write that? CaO. Would you expect that to be a solid, liquid, or a gas? Solid, yes. So now that we have our formulas written correctly, now we'll balance it. Always write them out, predict, balance last. Okay? How would I balance that? I need a 2 right here to take care of my oxygen, and then what does that do to the lone calcium? I need to put a 2 there. Okay? Now I have hydrogen plus chlorine. How would I write those two? H2, definitely a gas, plus, how do I write chlorine? Cl2, also a gas, making what's going to make? Tell me the formula. HCl. What would HCl be in terms of solid, liquid, gas? It would be a gas. How many of you thought, oh, it's an acid, it's going to be aqueous? We don't have any water here. So this actually would not be an acid. This would actually be hydrogen chloride gas. If I added some water, then I could make it an acid. Okay. This one's easy to balance. I just need to put a 2 right there. Yeah? Okay. How about aluminum plus oxygen? Al plus O2 is going to make what? It's going to make aluminum oxide, but how would I write the formula? Not AlO2. There you go. Al2O3, which is going to be a solid. Okay. First thing I notice is I've got a 2 and a 3 for oxygen. The only way I can get those to bounce out is to make them both be what? Say 6. 6. There you go. So I'm going to put a 2 there and a 3 there. So I have 6 oxygen. They are now balanced. So what do I need to put in front of aluminum? 4. Or if you're British, aluminium. Okay? Leave room because we're going to do a couple more that are not on here that I want to make sure we go over. Okay? Because when we're making the acid, I need to show you a trick.
So, do you use the octet rule to find the substrates when?
Do I use the octet rule?
Yeah.
I mean, more or less. We know that aluminum becomes a +3 when it becomes an ion, and we know oxygen becomes a -2. So I bounce my charges like we did last unit. Yeah. But one thing we need to make sure we don't do, because a lot of times kids, when they're by themselves, like they would write Al3+ when it's over here by itself, and that's a big no-no, because when it's an element, it doesn't have a charge. It has a charge when it goes to the other side and forms up. Okay, so I'm going to erase all that. Let's do a couple of more examples. Let's do potassium oxide plus water. What would it make? Using your list, potassium is a metal, so I have a metal oxide plus water. What does it make? How would potassium hydroxide make calcium hydroxide? It would make potassium hydroxide, right?
Wasn't even in the example.
Huh?
Wasn't even in the example.
Yeah, it's magnesium, right. All right, so I need to balance that. What do I need to do to balance that? Put a 2 right here, and that takes care of everything?
Yes.
Awesome. All right, how about let's do, I just like to make these up as I go along. Let's stick with potassium and do K2O plus CO2 now. What does a metal oxide plus carbon dioxide make? It's right there on your paper.
Potassium carbonate.
Potassium carbonate, which would be K2CO3. Do I need to do anything to balance that? No, I do not. And then one last example we're going to have to play around with, and that is a non-metallic oxide. Let's do P4O10 plus water. What will it make? So what does your paper say about a non-metallic oxide plus water? What does it make? It makes an acid. Specifically, it's going to make an oxyacid because there's oxygen there. So we have to account for that. So I have phosphorus and I have oxygen, and I know I'm going to make an oxyacid. What are the only 2 polyatomics I have available to me to make an oxyacid with these 2 things? Phosphate and phosphite. How do I know which one? I don't. I'm going to work a little backwards. So no matter which one I use, phosphate or phosphite, I'm going to need how many hydrogen? 3, because both of them are -3. So I know I'm going to need 3 hydrogen. So I'm going to say 3H3PO blank for right now. Okay? I'm going to figure that out last. Okay? So first thing I'm going to do is I'm going to balance my phosphorus. So the only way I can balance my phosphorus is to do what? 4 what? I put a 4 right here. That took care of my phosphorus, right? Okay. So my phosphorus is all happy. Now, how many hydrogen do I have on my product side? 12. What's the only way I can get 12 on the reactant side? Put a 6. Now, here's where the magic happens. How many total oxygen do I have on the reactant side? 16. So what do I have to have my subscript be? 4. Fill in the blanks. Magic! Only real, because it's science. Yeah. So those you want to work a little bit backwards, because you don't know, do I have the PO4 or the PO3, so you figure it out that way. Okay? All right. Yes?
It seems like most of these are like almost an educated guess. Use like certain patterns to make an educated guess. Is that how it works?
I mean, I would refrain from saying educated guess, but I can see how from your standpoint, from the student standpoint, yeah. But, I mean, honestly, I'm giving you what these things make. You just have to put them together based on their charges. Yeah. Yes?
If the options are narrowed down like that, like just phosphate.
So the reason we could narrow down that it was only phosphate or phosphite is because it's P, yeah.
Yeah, and those are the only 2 options.
So, yeah, like if I was doing something with like sulfur oxide of some sort, then I could only do SO2 or not SO2, SO3 or SO4. If I had nitrogen dioxide, I could figure it out that way too.
So, like, if the options were narrowed down like that, could you just use both of them and see which one works?
Yeah, but isn't this way faster? Yeah. Yeah, it doesn't take very long to, yeah, for sure. You could try both of them and see what works, but then you're doing twice as much work. Yeah. Okay, so that brings us to decomposition. Those are examples from the lab. We are not doing the lab until after Thanksgiving, so we'll come back and talk about examples from the lab. Decomposition. Okay? It's the opposite of composition. We're breaking it down. We're taking one one reactant and breaking it down into two simpler things. So the way that we will recognize decomposition is one reactant. It is the only one of them that will only have one reactant. So if you're looking at a list, they're usually the easiest to pick out because there's only going to have one reactant. Okay? And of course, if you look through the list that's below that, they're pretty much the opposite of the composition. For instance, if I have an ionic compound, what is it going to break down into? A metal and a nonmetal. And if I have a covalent molecular compound, it's going to break down into two nonmetals. Okay? And then some compounds may decompose into an element in a compound. For instance, hydrogen peroxide will break down into water and oxygen. Okay? Then we can have metal carbonates. They're decomposing into metal oxides and carbon dioxide. A while ago we said a metal oxide plus CO2 makes a metal carbonate. It makes sense that a metal carbonate breaks down into a metal oxide plus CO2. Okay? Only one that wasn't on your list for composition was these metal chlorates. Metal chlorates will break down into a metal chloride plus oxygen. Okay? And metallic hydroxide breaks down just exactly opposite. All right? Again, don't try to figure these out yourself. Use the list. It's there for a reason. I'm giving you all these things for a reason. All right, so let's practice. Potassium carbonate. Notice it doesn't have anything in there. What?
Do we have that listed on my test?
Nope. Nope. You don't get that list on a test. It's pre-AP. How do I write potassium carbonate? Anyone, not just Dylan. K2CO3. What's it going to break down to? We have a metallic carbonate. What does your list tell you a metallic carbonate breaks down into? A metallic oxide plus CO2. So I know it's going to be CO2, so let's go ahead and throw that out there. How do I write potassium oxide? Huh? K2O. All right. Do I need to do anything to balance it? No, it's magic. Okay. Iron 2 hydroxide. Fe. OH2. And what does it say about a metallic hydroxide? What does it break down into? Metal oxide and water. So go ahead and throw water out here because we know that's coming. And how do I write iron 2 oxide? FeO. All right. Do I need to do anything to balance that? Nope. Okay. Potassium chlorate. How do I write that? Someone's got their pink sheet out. Good job. Okay, ClO3. And what does a metallic chlorate break down into? A metal chloride plus oxygen. So no oxygen out here. Metal chloride, KCl. Uh-oh, I need to do something about balancing that. First thing I notice is 3 and 2 for my oxygen. What do I want to make them be? 6. So I'm going to do 3, 2, and then I will need a 2 on KCl. And then how do I write silver oxide? Ag2O. Alright, so what is silver oxide going to break down into? Well, what is silver? A metal or a nonmetal? Metal. What is oxygen? Nonmetal. So I have an ionic compound. What is the only thing these could break down into? Metal and nonmetal. Silver plus, how do I write oxygen when it's all by itself? O2. So I need to balance that. So the only thing I can do is put a 2 here. So now my oxygen's balanced. And then now I need 4 silver. Okay? Any questions so far? And that's where we're stopping.